I am Dr. G. Nageswara Rao, Professor, Lakireddy Balareddy College of Engineering. The course is Hybrid Electrical Vehicles. The today's topic, Components of Conventional Vehicle. The course developed by Jawaharlal Nehru Technological University, Kakinada. In this video, I am going to discuss about major systems and components of an automobile. An automobile is made of several components, assemblies, and systems. The growing automotive industry has given rise to a growing auto components in industry also. The emerged as a global outsourcing hub for manufacturing of various automobile components. All major companies like Toyota, Hyundai, Ford, Volvo, Renault, and other are now resourcing their automotive companies. The auto components industry are predominantly divided into 5 segments. First one, engine parts. Second, drive, transmission and steering parts. Third one, suspension and brake parts. Fourth one, electrical parts. Fifth one, body and chassis. Coming to the first one, the global automobile manufacturers as a manufacturing hub for auto companies due to the some reasons, low cost labor force and availability of raw material which makes cost competitive, an established manufacturing base in the country, setting up of the operations of major internal auto components include Delphi, Weston, Bosch, and Mario in this particular country, setting up of international purchasing offers of automobile manufacturers and auto components manufacturers in the country, fine quality components manufactured in the country being a global hub for research and development, General Motors, Bosch, Johnson Controls, etc. In this particular video, you will learn about the various components and systems that make a complete automobile, the engine and its parts, the body and chassis, drive, transmission and steering parts, suspension and brake parts, electrical parts, and other systems that make running an automobile possible. Coming to the chassis and auto body. Chassis and chassis is a French term was initially used to denote the frame or main structure of the vehicle. The chassis contains all major units necessary to propel the vehicle, guide its motion, stop it, and allow it to run smoothly over uneven surfaces. It is the main mounting for all components, including the body. It is also known as carrying unit. The chassis includes the following major components. First one, a steel frame, which is a major part. Second one, in case of passenger vehicle, the whole body is also an integral part of the chassis. However, in commercial vehicles like trucks and buses, the body is not a part of the chassis. Therefore, a chassis is almost a complete vehicle except the body and other accessories which are not involved in the movement of the vehicle. Third point is other major components include engine, transmission system, front and rear axle, steering system, suspension system, wheels, tires and brakes. Coming to the functions of the chassis includes carrying the weight of the vehicle and its passengers, withstanding the engine and transmission torque and thrust stresses as well as accelerating and braking torque, withstanding the centrifugal force while taking a turn and withstanding the bending load and twisting due to the rise and fall of the front and rear axles. Coming to the automobile body or superstructure. In case of integral frameless construction, the body is an integral part of the chassis, but in case of the conventional chassis, the body or superstructure is made after receiving the chassis from the manufacturer. The shape of the body depends upon the ultimate use for which the vehicle is meant. The body of a vehicle is made of a sheet of metal or fiberglass so that passengers can sit in it. To make the journey comfortable, cushioned seats are provided. The body is provided on all sides with glass panes fixed to protect the passengers from the dust and rain. The body of a vehicle is made of metal like steel section pillars with steel sheet paneling, steel section pillars with aluminum paneling, and all aluminum bodies, that is pillars, framework and paneling made of aluminum sections and sheets. This is because aluminum is very light in weight compared to steel. This total is represented the body of a bus. The body of a coming to the body of a truck has a driver's compartment covered and the rest is kept open. Such bodies are generally called load bodies. In most of the cases, it is an open body, whereas for liquid metal like water, milk, and fuel products, a tank is mounted on the chassis. The body is fixed to the chassis with the help of I or U bolts with rubber packing placed between the chassis and the body cross members. Coming to the requirements of the automobile body. The body of a motor vehicle should fulfill certain requirements. It should be lightweight. It should have minimum number of components. It should have long fatigue life. It should have uniformly distributed load. It should have sufficient space for passengers and luggage. It should have good access to the engine and suspension system. It should have minimum vibrations when the vehicle is running. It should have minimum resistance to air, be cheap and easy in manufacturing. It should have clear all round vision through glass areas. It should also have an attractive shape and color. Coming to the another part, engine and its shows an engine is complex unit in which different components are assembled together and fuel is burned to produce power or energy. The engine converts chemical energy or heat energy into mechanical energy, which is then utilized for vehicular movement. There are different processes of fuel conversion. When the fuel is burned within the engine, it is called an internal combustion engine, IC. And when it is burned externally and the produced steam is to be used to the mechanical movement, it is called an external combustion engine, EC. Nowadays, automobile engines are quite economical due to the developments taking place in the field of internal combustion engine. On the basis of process of ignition, the automobile engines are classified into spark ignition engine, petrol or gas, and compression ignition, diesel. In an IC engine, The reciprocating motion of the piston is converted into rotary motion of the crankshaft, and the produced power is then transmitted to move the vehicle. In case of a rotary engine, the engine, the rotor rotates and completes the process of combustion and produces the power which helps the vehicular movement. The spark ignition engine can be differentiated from the compression ignition engine as per the factors. First one, the type of fuel used. Second one, the way the fuel enters in the combustion chamber. Third one, the way in which the fuel is ignited. Coming to the spark ignition engine, petrol or gas engine. The spark ignition engine uses a highly volatile fuel such as gasoline, which turns into vapor easily. The fuel is mixed with air before it enters the combustion chamber and forms a combustible air fuel mixture. This mixture then enters the cylinder and gets the compressed with the help of the piston. An electric spark is produced by the ignition system, which ignites the combustible air fuel mixture. The combustible gases burn and expand, which forces the piston downwards for generating power. Coming to the compression ignition engine, diesel engine. In the compression ignition engine or diesel engine, only fresh air enters the cylinder, which is compressed to a very high pressure and temperature, which go up to 1000 degree Fahrenheit. The diesel is then injected or sprayed into the engine combustion chamber. This spray contains very fine and tiny particles of the diesel in an atmospherized form. The hot air or heat of compression ignites the fuel and generates the power stroke. Coming to the components of an IC engine. First component, cylinder. The cylinder or cylinder linear of an IC engine is fitted in the cylindrical blocks, which is a single casted unit and is considered to be the main body of an engine. The block has cylinder liners. The piston reciprocates up and down from top dead center TDC to bottom dead center BDC to generate power. The cylinder liner and the cylinder block have to withstand very high pressure, about 70 bar, and temperature about 700 degrees centigrade during the power stroke. The material used for the cylinder block must withstand such heat and also disperse it effectively. The cylinder block is well designed with water passages to remove the excess heat, and separate oil passages are provided for the circulation of the lubricating oil. The top portion of the cylinder block is covered by cylinder head. The crankcase is an integral part of the cylinder block which houses the crankshaft, and the lower portion is dipped in an oil pan. Nowadays, cylinder liners are made of spherical alloy and internal portion is coated with material like titanium, which provides mirror finish and can withstand the wear resistance. The upper end of the cylinder liner has flange which fits well in the cylinder block. The exterior portion of the cylinder liner is exposed to water jacket for easy dispersion of heat. Coming to the second part, cylinder head. The cylinder head is also single casted unit and bolted to the top portion of the cylindrical block. The combustion chamber is a part of the cylinder head where the combustion of gases takes place. The water passages are provided to remove the heat from the cylinder head. In latest engines, the cylinder head also houses the crankshaft, which has the inlet and exhaust valves with supportive valve mechanism. This provision is made to fix spark plug in SI engines and nozzle in CI engines. The lower portion of the cylinder head is well machined to ensure there is no leakage of gases. Cylinder head gaskets is generally cast as one piece and bolted to the top of the cylinder. Copper and asbestos gaskets are provided between the cylinder and cylinder head to obtain a gas tight joint. The charge enters the combustion chamber through the inlet valve connected to the inlet manifold, and the exhaust gases are removed through the exhaust valves connected to the exhaust manifold. Coming to the third part, piston and piston rings. Piston is a cylindrical unit used to compress the charge during compression stroke and to transmit the gas force to the connected rod and then to the crankshaft during the power stroke. The pistons of IC engines are generally made of aluminum alloy, which has high thermal conductivity. The material of piston must have the ability for higher heat transfer. The piston moves up and down from TDC to BDC and assists in completing the engine cycle. The piston rings are placed in the ring groove and provide sealing between the piston and the cylinder liner, thereby preventing the leakage of high pressure gases. These are made of special grade cast iron which retains its elastic property even at very high temperature. The upper piston rings are called the compression rings and the lower pistons are called oiling or oil control rings. Coming to the second component, connecting rod. It is generally manufactured by using drop forged steel. It is made in the shape of capital I so as to reduce its weight and to withstand strength. Its small end is connected to the piston with the help of Gadgion pin and big end is connected to the crank pin with the shells bearings. It has a passage for the transfer of lubricating oil from the big end bearing to small end bearing. The major function of the connecting rod is to convert the reciprocating motion of piston to the rotary motion of the crankshaft. Next component, crank and crankshaft. The crankshaft is called backbone of an engine because it converts the reciprocating motion of piston into the rotary motion of the crankshaft. The crankshaft is a single casted unit and is made of drop forged steel main journals which are placed and supported in the crankcase. The main journal and connecting journals are machined to a smooth finish to reduce friction, and shell bearings are used for smooth rotation of crankshaft. Front end of the crankshaft will transmit drive to the crankshaft and also the timing gear, whereas the flywheel is bolted to the flange at a rear end of the crankshaft. Main journal of the crankshaft carries the oil passages to lubricate the shell bearings. In case of a single cylinder engine crank, At one side of the shaft, magneto is fastened, whereas clutch assembly is mounted to the other. The crank assembly is balanced dynamically as well as statistically for the smooth transmission of power. Coming to the another component, piston pin. This unit connects the piston and small end of the connecting rod and passes through the piston. Circlips are fitted into the reaches in the piston to prevent the gudgeon from touching the cylinder wall. The needle bearings or bronze bushings is press fitted into the connecting rod. Due to this, the pin provides the bearings for the oscillating small end of the connecting rod. Another component, inlet valve. The major role of the inlet valve is to fresh charge into the cylinder during the suction stroke. Opening and closing of the valve will control the admission of the charge into the petrol engine or air into diesel engine during suction stroke of an engine. The valve operations will be as per the valve timings. The inlet valve has a wider face, or in latest engines two inlet valves are used. Face are to maintain the volumetric efficiency of an engine. Coming to the another component, exhaust valve. The exhaust valve removes out the burnt gases from the combustion chamber after power stroke. The exhaust valve has to bear more heat resistance. Next component, valve spring. The valve spring plays an important role to close the valve and also provides airtight compartments to seal the combustible gases during power stroke and also maintain the self-sustaining movement of the valve. Both ends of the valve springs are machined for smooth function and up and down movement of the valves. Next component, inlet manifold. The fuel air mixer is carried out from the carburetor to the cylinder through a separate pipe through inlet manifold in a carburetor engine. Whereas in compression ignition engines, diesel, the air is sucked through the induction manifold. In MPFI, the engine holds the throttle body on top of the manifold and the supply of air is monitored by the throttle body sensor. Coming to the next component, exhaust manifold. It is a set of pipes and muffler which is used to remove the exhaust gases from the exhaust ports. Engines, oxygen sensors, and catalytic converters are used to reduce the sound and air pollution, respectively. Next component is crankshaft. The major function of the crankshaft is to operate the intake and exhaust valves through the cam lobe. The gear drive transmits the power for the rotation of oil pump. Therefore, the oil pump sucks the oil from the oil sump and transits the same to the oil gallery. The crankshaft is driven by the crankshaft at half the speed of the crankshaft. Next one is cam lobe and tappet. The cam lobe of the crankshaft is placed directly above the bucket tappet such that the lobe comes around it and pushes down the bucket tap and valve, thus opening the valve. In an overhead crankshaft with rocker arm, the crank lobe comes under the valve lifter. and causes the rocker arm to rock or run the lobe and pushes down the valve steam and it moves down to open. When the cam lobe passes the valve lifter, the valve spring retains back to the original length. The closed valve, the rocker arm turns back and valve lifter is pushed down on the cam in case of double overhead crankshaft engine. The double row valves are generally operated by the separate overhead crankshaft. And coming to the another component, push rod and rocker arm. The motion of the cam lobe pushes the valve lifter upwards. This movement pushes the push rod and the rocker turns the upward motion of the push rod to the downward motion of the valve stem, resulting in operating the valve. And coming to the next component, crankcase. The crankcase is an integrated part of the cylinder block. The casing is provided to hold the crankshaft. The crankshaft is allowed to rotate freely and transmit the power to the flywheel. Next component, water pump and water jacket. The function of water pump is to draw water from the radiator and supply it to the water passages provided in the cylinder block, and cylinder head is in with certain pressure. The circulation of coolant removes the excessive heat from an engine. This helps in maintaining the engine temperature and also the life of an engine. Next component is the radiator. The main function of the radiator is to radiate the heat from the coolants. It has two tanks located at the top and bottom. The upper tank is connected to the lower tank with the core through the passages for easy radiation of the heat. The radiator also stores the coolant. Coming to the next component, flywheel. It is an wheel mounted on the crankshaft which stores the energy during the power stroke and transmits the energy to the transmission system, the clutch and then the gearbox. Next component is governor. And in this governor, it is run by drive from the crankshaft. The governor of the function is to regulate the charge in case of petrol engine. And amount of fuel in case of diesel engine to maintain the speed of the engine constant when the load requirements varies. The components described here is commonly used for all types of the IC engine. And another component is the carburetor. The major function of the carburetor is to supply carburized fuel as per speed and the engine load. In petrol engines, the carburetor is mounted on the induction pipe or on the induction manifold. The quantity of fuel air mixer in appropriate ratio is controlled by the throttle valve, and the movements of the throttle valve are connected to the accelerator. Next component is the spark plug. The function of the spark plug is to ignite the fuel air mixture after completion of the compression stroke in an engine. It is generally placed in the combustion chamber of the cylinder head. And another component is fuel injection pump. In case of diesel engine, The diesel oil from the fuel tank is sucked by the fuel feed pump. The pump first sends the diesel oil to the fuel filler and then to the transfer pump. The transfer pump increases the pressure of the fuel. The high pressure of fuel is then sent to the distributed rotor through the metering valve, and from rotor the fuel is sent to the injector. In case of a multi-point fuel injection system, the electric fuel pump is used and placed in the fuel tank. The pump generates the injection pressure and sends it to the fuel filler and then to the common rail at a pressure of 3 to 4 bar. The common rail or fuel rail is connected to the fuel injector. Coming to the fuel injector, the function of fuel injector is to break the fuel into fine spray atmospherized condition as it enters the combustion chamber of the diesel engine. In case of an MPFI engine, petrol is injected at the end of compression stroke as the fine spray of the fuel burns more efficiently in the combustion chamber, giving better fuel efficiency with less air pollution. And coming to the another one component in this particular is lubrication system. As you know, our body requires fluids like water and also oil in form of fats like ghee, butter, cooking oil for maintenance of our system. Similarly, lubrication is required for maintenance of engine. Lubrication is system is one of the most important parts of an engine. The engine cannot run smoothly for more than a few minutes without the lubricating oil. Whenever two metallic surfaces move over each other under direct contact, dry or solid friction is produced. This is due to the irregularities on the two surfaces interlocking each other. The dry friction thus created produces a lot of heat and results in wear and tear of the metal surfaces. Coming to the objectives of lubrication, the main objectives of the lubrications are to reduce friction between moving parts to its minimum value so that power loss is minimized, and to reduce wear and tear of the moving parts as much as possible. Apart from these objectives, lubrication also serves other important purposes which may be called secondary. These are: first one, to provide cooling effect. The lubricating oil takes heat from the hot moving parts during its circulation and delivers it to the surrounding air through the crankcase. Second one, to provide cushioning effect. The lubricating oil also serves as a good cushion against the shocks experienced by the engine. For example, instant combustion of the fuel in the combustion chamber produces a sudden rise of pressure in the cylinder, and the shock goes to the bearings through the piston, guidon pin and the connecting rod. This shock is then absorbed by the layer of oil present in the main bearings. And next secondary point is to provide cleaning action. The lubricating oil serves another useful purpose for providing a cleaning action during its circulation. It carries away many impurities such as carbon particles, etc. And another point is to provide a sealing action. The lubrication oil also helps the piston rings in maintaining an effective seal against the high pressure gases in the cylinder thus preventing leakage towards the crankcase. Now coming to the cooling system. Like our body requires air and water for cooling our system, similarly the engine of a vehicle also requires cooling. The cooling system has three main functions, which are: first one, removes excess heat from the engine. Second point, maintain a constant engine operating temperature. Third point, increase the temperature of cold engine as quickly as possible by maintaining the thermostat value in a closed piston which is fitted in the path of a coolant circulation. What is the necessity of cooling? The cylinders of internal combustion engines require cooling because the engine cannot convert all the heat energy released by the combustion into the useful work. The liquid cooling is employed in most of the engines, whether they are used in automobiles or elsewhere. The water or coolant is circulated around the cylinders to pick up the heat and then dissipated it through the radiator. As the temperature increases from 71 to 82 degrees centigrade, the thermostat valve opens and sends the water to the radiator to radiate the heat. When the temperature rises above the 82 degrees, the thermostat switch operates the cooling fan to support the cooling process in the radiator. Coming to the next component, fuel supply system. The fuel supply system in petrol engines, the fuel and a mixer is supplied to the combustion chamber of an engine. The mixer is atomized and then vaporized by the carburetor. Then the mixer is ignited by the spark plug. The fuels such as petrol, benzoyl, and alcohol are used in an SI engine nowadays. Fuel is injected in flow of air at certain temperature and pressure, and the fuel vaporizes faster and the combustion process is better with low emission. It also shows better fuel efficiency. In case of compression ignition engine diesel, the fuel is sent through the fuel pump to the injector and the injector sprays the fuel at the end of the compression stroke. The oil fuels which are used in CI engines do not vaporize easily. Therefore, a separate injection system is used consisting of fuel injection pump, FIP, and injectors. These injectors atomize the fuel and it is then sent for combustion. Nowadays, in case of the compression, ignition engine is common rail direct injection system is used for better engine performance. Coming to the fuel supply components. The fuel supply components includes the components. One is the fuel tank, fuel line, fuel filter, air cleaner, fuel injection pump. Coming to the fuel tank, in most of the vehicles, the fuel tank is located at the rear end of the vehicle. The fuel tank is made of metal sheet or plastic. It is attached to the chassis. The filler opening is closed with a cap. The fuel line is attached to the fuel pump and also to the fuel gauge. And another one is fuel line. Fuel line carries the fuel from the fuel tank to the carburetor or to the common rail system used in MPFI engines. The line has to withstand the pressure and provide resistance for the corrosion. The rigid line is placed safely in the chassis. It is connected to the units like carburetor through a flexible pipe. Coming to the another component, fuel filter. The major role of the fuel filter is to send clean fuel to the engine. This prevents the blockages in the fuel system. The filler contains the cartridge of filtering the elements through which the fuel passes. The filter traps any particles from the prevents them from entering the fuel system. The fuel filler is required to be replaced at regular intervals. Coming to the another component, air cleaner. It is the main unit of the fuel system. It supplies clean air to the engine. The element of the air cleaner must be cleaned and replaced at regular intervals for maintaining a healthy life of the engine. Next component, fuel injection pump. In case of a diesel engine, the diesel oil from the fuel tank is sucked by the fuel feed pump. The pump first sends the diesel oil to the fuel filter. From there, it is sent to the transfer pump. The transfer pump increases the pressure of the fuel. This high pressure of the fuel is then transferred to the distributor rotor through the metering valve. From the rotor, the fuel is sent to the injector. In case of multi-point fuel injection system, the electric fuel pump is used. The pump generates the injection pressure and sends it to the fuel filler and then to the common rail at the pressure of 3 to 4 bar. The common rail or fuel rail is connected to the fuel injector. Coming to the fuel injector. The solenoid injector used in the MPF5 fuel system is operated electrically as per the variation in the supply of current with resistance. The solenoid winding induces current within it and controls the movements of the needle valve to inject fuel as per the variations in speed and the load. The fuel system is controlled by the ECM. Coming to the next component, pressure regulator. It controls the amount of pressure that enters the injector. The exact fuel is sent back to the fuel tank. Now this slide shows the comparison between fuel supply components for SI engine, fuel supply components for CI engine. For SI engines, fuel tank, fuel lines, fuel pump, fuel filter, carburetor, inlet manifold, air cleaner. But in CI engine, fuel tank, fuel lines, fuel feed pump, fuel filters, fuel injection pump and fuel injectors. This is the comparison table between the SI engine and CI engines. Coming to the another component, transmission system. Transmission system is used in motor vehicles to supply the output of the internal combustion engine to drive the wheels. The transmission reduces the higher engine speed to the lower wheel speed, increasing the torque in the process. Transmissions are also used to pedal bicycles, fixed mechanisms, and where the rotational speed and torque needs to be adapted. And coming to the transmission system. The transmission system consists of the mainly the components clutch assembly, gearbox assembly, propeller shaft. Coming to the clutch assembly, the clutch is a mechanism which enables the rotary motion of one shaft to the transmitted when desired. The axis of the driving shaft and drive shaft are coincident. Now coming to the functions of the clutch, to disconnect the engine power from the gearbox as required under following circumstances, to start the engine and warm it up, to engage the first and second gear to start the vehicle from rest, to facilitate changing the gear as required. And another function of the clutch is disconnect from the engine to stop the vehicle after application of brakes, to allow the engine to take up load gradually without shock or jerk. What are the requirements of the clutch? The clutch should meet the requirements: torque transmission or ability to transmit maximum torque of the engine, gradual engagement, that is to engage gradually and avoid sudden jerks, heat dissipation, dynamic balancing, vibration damping. Size and clutch should be as small as possible so that it occupies the minimum space. Free pedal play, which helps the clutch to reduce the effective load on the carbon thrust bearing and its wear. Easy in operation and requiring as little exertion as possible on the part of the driver. Lightweight of the driven member of the clutch so that it does not continue to rotate for any length of the time after the clutch has been disengaged. What are the main parts of the clutch? The main parts of the clutch are divided into three groups. First one, driving members. Driving members consists of a flywheel mounted on the engine crankshaft. The flywheel is bolted to a cover which carries a pressure plate or driving disc, pressure springs and releasing leaves. Thus, the engine assembly of the flywheel and the cover rotate all the time. The clutch housing and the cover provided with the openings dissipate the heat generated by the friction during the clutch operation. Next one is driven members. The driven members consists of a disc or plate called the clutch plate. It is free to slide lengthwise on the splaners of the clutch shaft. It carries friction materials on the both of its surfaces. When it is gripped between the flywheel and the pressure plate, it rotates the clutch shaft through the splaners. Next one is the operating members. The operating members consists of a foot pedal, linkages, releasing bearing, release levers and the springs. Coming to the gearbox assembly, we need different gear ratios in the gearbox or transmission system to enable the vehicle to move at different speeds. At the time of the starting the vehicle, the maximum amount of torque is available on the flywheel, for which low gear ratio is selected for movement of the vehicle. As the engine speed increases, the amount of torque is reduced on the flywheel and it is required to select higher gear ratio. Now coming to the functions of a gearbox. To provide a means to vary the leverage or torque ratio between the engine and the road wheels as required. Next one, the transmission also provides a neutral position so that the engine and the road wheels are disconnected even with the clutch in the engaged piston. Next function is it provides a means to reverse the vehicle by selecting the reverse gear. Next components is the front and rear axle. In this, I am going to discuss the axle and steering system which transmits the power to the wheel. It plays a circular role in the movement of the vehicle. Propeller shaft. This is a shaft which transmits power from an engine to the wheels of a motor vehicle. It is a hollow tubular shaft and consists of the mainly three parts: shaft, universal joints, split joint. Coming to the shaft, it mainly bears the torsional stress produced due to twisting. It is generally made of tubular cross section. Next one, universal joint. One or two universal joints are used depending on the type of rear axle drive used. The universal joints help in the up and down movements of the rear axle when the vehicle is in the running condition. Next one is split joint. Depending on the type of the drive, one slip joint may be there in the shaft. This is several to adjust the length of the propeller shaft when demanded by the rear axle moment. Next one is the front and rear axle. In the front axle carries the weight of the front portion of the automobiles as well as the facilities steering and controls the rolling of wheels. It also absorbs the road shocks arising due to the road surface variations. In case of a commercial vehicle, the front axles are generally dead axles. The front axle is designed to transmit the weight of the automobile from the springs to the front wheels, turning right or left as required. To prevent interference due to the front engine location and for providing greater stability and safety at high speeds by lowering the center of gravity of the road vehicles, front axle includes the axle beam, subaxles with the brake assemblies. It is made of drop forget alloy steel consisting of 0.4% carbon steel and 1.3% nickel steel. The main beam axle is connected to the stub axle with the kingpin. The front road wheels are mounted on the stub axles. Next, coming to the rear axle. Like the front axle, the rear axle also made up of dropped forged steel. It enables to transmit the driving and braking torque to the chassis, frame and body of the vehicle. It also bears the sides through the pull down any side of on the vehicle. Now coming to the steering system. The steering mechanism permits the driver to control the vehicle on a straight road and turn right or left as desired. The steering mechanism includes a steering wheel which driver controls the steering gear, which converts the rotary motion of the steering wheel into the straight line motion and steering linkages. In modern vehicles, the manual operated steering system is assisted by the power and is called power steering. The electric power drawn from the battery or hydraulic power is used. The functions of the steering systems are: it provides directional stability to the vehicle when moving in a straight direction. It provides perfect steering condition, that is, perfect rolling motion of the wheels at all times. It facilitates straight head recover from after completion of the turn. It controls the wear and tear of the tire. It is used to turn the vehicle as per the will of the driver. It converts the rotary motion of the steering wheels into angular displacement of the front wheel. It multiplies the efforts of the driver to easy operation. It absorbs the road shocks and prevents the road from the reaching the driver. Now coming to the what are the requirements of the good steering system. It should be very accurate. It should be easy to handle. The efforts required should be minimal. It should provide directional stability. The front wheel should roll without lateral skid while negotiating curves. There should be proper proportion between the angles turned by the front wheels. The tire must have good elasticity so that on the turns these may fall an arc of the greater radius than the shift tire. The wheel should automatically come to the straight head portion after negotiating the bend when negotiating straight, while the wheels must contain the neutral position. The angular oscillations of the wheels must be minimum. The system must irregular and irreversible to a certain degree so that minimum front wheel shocks are transmitted to the driver's hand. Coming to the steering mechanism, for perfect steering, it must always have an instantaneous center which all the wheels must rotate. To achieve this, the inner wheels has to turn more than the outer wheel. Two types of the mechanisms are available: the Davis and the Ackermann steering mechanism. Out of these, Ackermann type is more popularly used because its simplicity. It also lessens wear the tire and lower friction. Steering linkages. A steering linkage is the part of an automobile steering system that connects to the front wheels. In a commercial vehicle, a grid axle type front suspension system is used. Steering wheel. It is made of polythene or hard plastic. It consists of a circular rim with a hub of at the center. Steering column, steering shaft, drop arm, drag links, steering gears. And coming to the suspension system, the suspension is the term given to the system of springs, shock absorbers and linkages that connects the vehicle to its wheels. The suspension system serves a dual purpose, contributing to the vehicle's road holding and handling and braking for safety and driving comfort, and keeping the vehicle occupants comfortable and reasonably well isolated from road noise, bumps, and vibrations, etc. Coming to the functions of the suspension system, the main functions of the suspension systems are to safeguard the occupants against the road shocks and providing riding comfort, to minimize the efforts of the stresses due to road shocks on the mechanism of the motor vehicle and provide a cushioning effect, to keep the body perfectly in level while traveling over rough uneven ground. That is, the up and down movement of the wheel should be relative to the body, to isolate the structure of the vehicle from the shock loading and vibration due to the irregularities of the road surface without impairing its stability, to provide the request height to the body structure as well as the bear the torque and braking reactions. And coming to the various components of the suspension system, the components of the suspension system can be categorized as mechanical suspension system, hydraulic suspension system, air suspension system. Coming to the mechanical suspension systems are subclassified as leaf springs, coil springs, rubber springs, torsion bears. And coming to the hydraulic suspension, subclassified into hydraulic shock absorbers, telescopic fork absorbers. Now coming to the here is, and another component is the wheel. The wheel is an important component of a vehicle. Wheel of four-wheeler vehicle is mounted on a hub and consists of the parts like rim, tire and tube. The wheels not only support the weight of the vehicle but also protects it from the road shocks. All the four wheels must resist the braking stresses and withstand the side thrust. A wheel should be light and easily removable. And now here is the what are the functions of the wheel. The functions of the wheels are to withstand the weight of the vehicle, to absorb road shocks, to grab the road surface. Next point is to unbalance, to balance dynamically. And coming to the another component is the rim. Another component is rim. The rim is the outer edge of the wheel holding the tire. It makes up the outer circular design of the wheel on which the inside edge of the tire is mounted on the vehicles, such as the rim is a large hoop attached to the outer ends of the spokes of the wheel and holds the tire of the tube. And different types of the wheel rims are disc wheel rim, wire spoke wheel rim, split wheel rim, heavy vehicle wheel rim. Next one is coming to the tires. The tire is mounted on the wheel rim. It carries the vehicle load and provides the cushioning effect. It must produce minimum noise while the wheel turns on the road. It resists the tendency for the vehicle to oversteer. It should have the good grip while accelerating and braking the vehicle on both dry and wet roads. Now, what are the desirable properties of the tires? Are a tire must have the desired properties: non-skidding, uniform wear, load carrying, cushioning, power consumption, noise, and balance. Coming to the functions of the tire, to carry the load of the vehicle, to absorb minor road shocks, to reduce vibration to some extent, to transmit the power from engine through gearbox, propeller shaft, and rear axle to the ground with which the vehicle moves. The trends made on the tires grip the road for better traction. Types of tires: solid tire, tube tire, tubeless tires. Now, coming to the brakes. Brakes are one of the most important control components of the vehicle. They are required to stop the vehicle within the smaller position possible distance and is done by converting the kinetic energy of the wheel into the heat energy which is dissipated into the atmosphere. The requirements of a good braking system is to stop the vehicle in the shortest possible distance and time, to control the vehicle speed while moving on plain roads and hills, to work equally well on fair and bad roads, to ensure that the pedal efforts applied by the driver is not much, thereby reducing the inconvenience for the driver, to work efficiently in all weathers. It should have very few wearing parts. It should require little maintenance. Brake when applied should not disturb the steering geometry. There should be minimum sound when brake is applied. Coming to the types of brake: foot brake, hand brake, drum brake or internal expanding brakes. Next one is disc brake or external contracting brakes, mechanical brake, power brake, vacuum brake, air brake, hydraulic brakes. And another one is anti-lock braking system, electric brake. Now here is electrical or mechanical systems. Nowadays, all the automobiles run with the help of electrical and electronic system, and therefore it plays an important part in the functioning of the automobile. The electrical and electronic system consists of starting system, ignition system, generating or charging system, lubricating system, connections for other accessories. The main components of the electrical systems, now here is starting system, generating system, charging system, ignition system, lighting system and accessories. and the functions of the each one is represented. Air conditioning systems. During summer, an automobile requires considerable amount of refrigerating capacity to maintain cool and comfortable conditions in the sitting space. Similarly, when moving in a cold days in winter, the same vehicle could require considerable heat capacity to keep it comfortable, warm for the passengers. So, different components of the automobile air conditioning systems: compressor, magnetic clutch, condenser, receiver dryer, expansion valve, evaporator, throttling valve.